So this part here, example 9, we're talking about evaluating exactly. Now, even if I don't use the word exactly, even if I said evaluate, you should know, okay, you should know when to find exact answers. Okay, when do you find the exact answers? I'm going to go over that with you right now, right? So you should know when to find exact answers. In grade 11, we said whenever you got 30, 60, and 45, you know those were exact, right? So whenever you had an answer with a 30, 40, or 65, you know those are exact. So this year as well. Oh, and also from grade 11, we also knew 0, 90, 180, 270, 360. Those were all exact answers, right? We should be able to find those by using our special triangles or our, so whenever I did the 30, 60, 45, I would go to the two special triangles. So special, oh, I can't spell special. Special triangles, okay. Special triangles, right? So these are the special triangles here. And then for this one, I told you to go to the graph. So I said for the sine graph and the cosine graph. So that's the sine and the cosine, right? So for these ones, I would say 0, 90s, that's how you would find that. So for these ones, I go to those, and for these ones, I would go to the special triangle. The same thing holds true when you are doing radians. So when I see, so the same idea as when we did these guys here, I shouldn't have had to tell you last year when to do exact because you knew anything with a combination of 30, 60, 45, you should know exact. So the same thing will be for radians. For radians, we know it's going to be any combination of pi over 30 is pi over 6, right? Pi over 3's, pi over 4's, right? 0, so it's 0, it's still 0. It'll be pi over 2, pi over, or sorry, pi, which would be 180, right? 270, 3 pi over 2, 2 pi's. Any of those should all be exact. Now, this can also be combined with any combination of the pi over 6. So when we have our pi over 6, we know that that is on our first quadrant, pi over 6. Right, so pi over 6. But also that pi over 6 can be flipped over to the next quadrants. So if this is pi over 6 for this, okay, if I'm going to flip it over here, what would the angle be over here? How much is that? So if this is pi over 6, and we know that these are always the same, okay, what's the slice? If I go all the way over here knowing that's pi over 6, that should be 5 pi over 6. Does that make sense? Because it's 6 to make the half, so it's 5 pi over 6. Good? All right. Then if I was going to flip it over into the next quadrant, so whoosh to here, how much would that be? Not 5 pi over 6, but add one more. That's 6 over 6, 7 pi over 6. Does that make sense? Okay. Then if I was going all the way, where's my last place it would be? Over here, all the way around. The same angle there. How much would this be? 11 pi over 6. So instead of 12 slices, it's 11. So if I see 11 pi over 6, 7 pi over 6, 5 pi over 6, or pi over 6, so any of those, right? And do you have to memorize those? No. That's what we were trying to get you to understand, the acute angle. So what's the acute angle related to 5 pi over 6? Pi over 6. What's the acute angle related to 7 pi over 6? Oh, it's pi over 6. And for 11 pi over 6, it's pi over 6. So you can see the acute angle. That's why they want you to understand the acute angle, because it's all these pi over 6 slices. So that tells me right away this is one of those special angles. It's 11 pi over 6. You cover up the 11, you know it's a pi over 6 combination. Okay, so that holds true for the other ones as well. So that's the pi over 6. So if we were to do the same thing, okay, so understand the slices. So I'm hoping you can see them now better. So this first one here, if I said this was pi over 3 for that one, and I want you to flip it over here, how much would it be if I went over here? Pi over 3, that would be 2 pi over 3. Good? Right, knowing that this is the same dot, same acute angle. And then what if I wanted to come over into this quadrant? Whoosh. And that's the same. That's pi over 3. That's 3 over 3. So this would be 4 pi over 3. Is that making sense? Okay, and then the last quadrant, so we're going to go over here. We know that's the same acute angle, so all the way around, how much would it be? That's pi over 3, so that would be 5 pi over 3. Instead of 6, it's 5 slices. Good? Okay, and then let's finish it off and just do the quarter one, just so we have that all down pat. And again, same idea. So we're trying to be able to picture the acute angle. If we know it's 5 over 3, then the acute angle is pi over 3. If we know it's 4 pi over 3, the acute angle is still pi over 3. If we know it's 2 over 3, the acute angle. So if my last one would be here, pi over 4. So that's pi over 4 for here. And I flip it over to this quadrant here. That would be how much? 4 over 4 minus 1 slice, 3 over 4. Good? Okay, and then flip it over here, knowing that's still pi over 4, so we flip over here. How much is this? 4 over 4, 5 pi over 4. Okay, good, following, and then, and then all the way around this way. If that's 4 pi over 4, so it'll be 8, so it'll be 7 pi over 4. Are we good with the slices now? Okay, so at first when I do that, it's kind of like, where are all these slices coming from? So I'm hoping now you kind of go, okay, that makes a bit more sense. We've got the slices, we're good. Okay, so then knowing that, when you see this question, you should be going, oh yeah, the acute angle is pi over 6. The acute angle for 2 over pi is pi over 3, and the acute angle here is pi over 4, right? So that's why you should recognize that this is an exact answer question. Sometimes we say evaluate exactly, and sometimes we don't, right? Sometimes the test is that you should know when it is exact and when it isn't. And we might say that on the instructions, that, okay, use exact whenever possible, right? And you have to know what's possible. So that means that's what this means, right? So you should know when to use the exact. All right. I'm going to draw these guys on the quadrants. I'm going to draw all 3. I left a lot of space here. You don't have to. Some people just draw a little quick something and they go, oh, I know it's acute. I use the cast rule. I'm okay. So you don't have to draw it as detailed as me. I'm going to draw it here for you. Make sure if you are drawing it, you're not going to spend too much time on it, though, right? It's a quick diagram. If you're not going to draw it and you do it faster, that's fine as well. So I'm going to draw all of these ones. So I'm going to go 1, 2, and I'm going to do 3. So I'm going to do all 3 on 3 quadrants so that I can just see them. And again, so you're not trying to, you're able to read my question. So first one, 11 pi over 6 is, I know I just talked about that. So it's 11, so it's almost 12, so it's over here. Okay, so that's 11 pi over 6, right? You don't even have to label if you're doing it rough. Drop, I know that this little acute angle here, the leftover is pi over 6, right? 1 slice left. Drop it always towards the x-axis at a right angle. If I know that that is 11 pi over 6, that's a pi left, 1/6 left. That is how many degrees? Pi over 6? 30. Are you converting it in your head now, right? 180 divided by, yeah, right? So that's why it becomes much more natural, but you know that's 30. Across from 30 is the smallest angle, so it's the smallest side. It's 1. And we're never going to forget that on the cast rule, you must remember the negative, right? Again, that is where people lose the marks. We don't want to at all ever take it off, but we will. So that we want negative. Then that's going to be, that's the 1. The 2 is always the hypotenuse. It's always positive, and this is root 3. Okay, across from the smallest angle is the smallest side. Make sure it's negative, and then you can put your answer in here. So this one here is going to be tan squared. So that's going to be tan is opposite TOA. So it's -1 over root 3. And remember, it is squared. So we're going to do this and squared because of this. It goes on the outside. Again, we haven't done trig in a while, so I'm just reminding you. Okay, I want to see this step. I need to see each one of these ratios. Do not square it in your head and go 1/3. Okay, I need to see this step with the negative. So we're going to we mark this. I want to see that ratio. Oops, sorry. That's an ugly check mark. Okay, I want to see that ratio, please. So show me the ratio, not just 1/3. So don't square it and give me 1/3. Okay, I want to see that with the negative. I know it's going to go away. It's still, you have to write it. Okay, the next one, sine squared 2 pi over 3. So I'm going to draw it over here. So it's 2 pi over 3. It's going to be 2 pi, so it's going to be 2/3, so it'll be over here somewhere. I take it, drop it at a right angle, and put my angle there. So I know that this is 2. It doesn't have to be to scale or anything, 2 pi over 3. This leftover one is the pi over 3, which I know is 180 divided by 3, 60. Right? So you should hopefully be converting. Okay? So then we know to label these side lengths. If that's 60, we just talked about this, right? Across from the smallest angle would be 30, so that's 1 here. This is root 3, and this is 2. And we must remember this is negative. Again, I'm not marking the diagram. So if I don't ask for the diagram, you don't have to put the negative. You have to just remember it's cast rule, right? That it's negative. If I ask to label the diagram, I'm going to mark to make sure it's got the negative. If not, it's rough. It's your own rough work. Okay, so you don't have to label everything, but okay, if I'm asked to mark it, then I want to see it all properly. If not, you want to remember it anyway, though, right? So you want to remember it's from there. So sine squared is going to be so it's opposite over hypotenuse. So I'm going to do over here, it's going to be root 3 over 2. I didn't even use the negative because it's in the sine quadrant, right? So I didn't even need it. So it's root 3 over 2. And again, grab this squared and put it there. Okay, it goes on the outside, so fill that in. Okay, so again, you can do this faster. I'm just showing you each one of my diagrams. And then pi over 4, you don't even have to draw them in the quadrants. If you know it's the acute angle and you know which quadrant it's in, you can do this much faster too. Yeah?
Is it not supposed to be root 3, not root 2?
Oh, sorry, root 3. Yeah, thank you. Thank you, root 3. Yeah, root 3 over 2. Good. And then here, thank you. And 5 pi over 4, so that's in this quadrant. I tried to give you a different quadrant, so that's 5 pi over 4, whoosh, over here. 5 pi over 4. So some people just go, I picture the acute angle, drop it down. This here is pi over 4. So then I know this is -1, -1, right? So it's backwards and down, root 2. -1, -1, root 2. So both of them are negative. Again, not relevant except for, yes, for cos, it's going to be negative there. Right? So some people don't draw the quadrants, they just draw the triangle and remember which quadrant it's in, right? And it's which quadrant, it'll be negative. So you have more than one way to do it, but this works too. Then we have, so ka is adjacent over hypotenuse, so it'll be -1 over root 2. So I'm going to take -1 over root 2, drag it up here. So minus -1 over root 2, bracket, no squared. So don't square everything. Okay, so make sure you show this whole step, yes, each one, not just don't go ahead and calculate it. I want to see this, so I want to see this whole thing. So yes, I'd like to see all these steps here, beautiful, beautiful. Then you can go ahead and calculate it. So now I'm going to go, this squared is going to be 1 over 3. This squared will be 3 over 4. And this is still just plus 1 over root 2, negative. You can't add these together until we rationalize. So yes, that rationalizing we have to do. Okay, and keep going. You can add these or you can wait. It's up to you how you do the fraction. And this will be root 2 over 2. Lowest common denominator would be 12, so 4. And this would be 4 plus 9, so 13, plus 6 root 2 all over 12, and leave that. That's beautiful. Okay? That's it. Yes?
How do you determine what was negative and positive, like on the triangles, is like based on the coordinates, right?
Yeah, so I do the coordinates, which is also the cast rule. Like the cast rule is these coordinates. So here, when you're doing tan, you know you have to grab that negative side because it's in the C quadrant. So it's automatically grabbing it. The sine was in its own quadrant, so you only use the positive sides. And then the cos here, it's in the tan quadrant, so you're using one of the negative sides. Right? So then it always fixes. The negatives are what the cast rule was all about. So if I do it on the quadrants, I don't have to worry about it. Some people ignore this and go, but it's in the T quadrant, so then I do it from there. So that's why you don't technically have to do the negatives unless I ask you to do the, label your diagram. But yeah, so I look at the side lengths, but you can also do it from the cast rule. Yeah, so either way, yeah.
Would negatives cancel out or no?
Yeah, so if I did tan here, look, CAS, this is tan's quadrant, negative and negative cancel out to be a positive. And that's why, yeah.
Say if it wasn't in the tan quadrant,
Yep.
And it was a negative,
Yep.
would there be two negatives or just one?
So right here, I put a negative in front, and then this one here, right? Then they cancel out to be a positive. But nothing else here will be a cancel out. Yeah, it'll cancel just the side lengths. Yeah.
For the final answer, do you have to put like radians?
It's not an angle. We found this is tan of this, which is a ratio. So these guys here have no units. It's a ratio of side, ratio, yeah. So when you're finding the angle, it'll be radians, and when you find the ratio, no units. Yeah, so no units for that, yeah.
So it kind of just fixes itself up.
Yeah.
If you just do it.
Yeah, if you do it with the signs, it fixes itself. That's why I had another student who was like, but I should put a negative in front of it because but the sign is already giving you the negative. So like here, they're like, should I put a negative because it's a negative in the tan? But I said, but you grabbed it and you took the negative from here, which is already telling you negative. You don't also have to put a negative in front of it, right? Because I had someone else who's like, but I'm putting a negative because it's in the C quadrant. I'm like, no, but that's why you grab the negative, so it's already doing, this is the cast rule, the negative positive stuff. Yeah, so you don't have to do another negative. Yeah, I know. I had some I was like, nope, don't do an extra one because you're trying to overcompensate. So because you grab the negative, that's already the negative from the cast rule. You don't have to do another one. Yeah. Okay, that makes sense. So it's a lot of cast rule, a lot of stuff. We just did a whole bunch of stuff in one question. Okay, and radicals and be able to do that. All right, last one. Last example for this section, we have here, look how many examples we had. This one here, it throws you off because I gave it to you in radians. So if I gave you the same question and I said, here we go, and I said this is, say, 160 degrees, and I want to find, and I said, say this was 5, and I want to find x. What would be your first instinct? So if I said this was degrees. And I said, I want to find the length of x. What would you do first? Yeah.
Find the angle.
Yeah, find this one. So say it's 20. There we go. Uh-oh. Did the screen just go off for a second? Okay. So we go 20, and then you'd use what? It's a right angle triangle. Yep. Yeah, so SOHCAHTOA, right? SOHCAHTOA, and that would be opposite and hypotenuse, so I do sine. Same thing here. I give it to you in radians, and you're like, uh-oh, what do I do? Same idea. We're going to find the missing angle, but keep it in radians. Okay. I forgot to tell you what to round to. Let's say to the nearest hundredth. We always tell you, right, on an evaluation, read the instructions or the question. So I'll do this one here. I should have put that down. I'll fix that later. But it's the same idea as this. So picture it in degrees and go, well, my first instinct would be to find the missing angle. I know that this is 90 degrees. I should have put the 90 degrees. That's my fault. I should have put the 90 degree on the question. And then you go, okay, then I'm just using SOHCAHTOA. So same idea, right? So picture degrees and go, I would find the missing one. So that'd be my first step. I'm going to say this one here, this angle here is going to be pi minus 2.3 radians. And that gives me, I kept 3 decimal places because I wanted nearest hundredth. So I'm going to go approximately 0.842 radians. And look, I kept 1 extra decimal place. I always do that just so that my rounding doesn't get in the way of an answer. right? So sometimes you round twice and it's a little bit off. So I kept that. So that's my missing angle. So just like this. So if I said, okay, that was 20, then I would just do SOHCAHTOA, right? So picture a degree. When I do radians, you kind of get thrown off, and it's the same thing. So I found my radian. This is a right angle. I should have put 90 in the original question. That was my fault, right? It's a 90. If you have a 90-degree triangle and you have this side, this is the opposite, right? And this is the hypotenuse. So using SOHCAHTOA, right? Using SOHCAHTOA, I know it's my O and H. So then I'm going to go sine, and then you use this as your angle, right? So this is your angle, 0.842 radians equals opposite over hypotenuse. So 1.3 over, and they said hypotenuse is x. And that's it. And now we just have to solve. Right? The setup is usually the hardest part. It's like, okay, so just picture degrees. So picture its degrees, find the missing angle, and SOHCAHTOA. And then I'm going to just bring this up here. So x sine 0.842r equals 1.3. To get rid of this, I divide this away, right? You can do this faster if you can, but just to show you my steps. That cancels off, and then you're left. So x is going to be approximately. Now, on your calculator, anytime you press sine, cos, or tan, you have to make sure you're in the right units. Is it degrees or radians? This is in radians. So on your calculator, make sure you switch it so you're in mode, and then degrees. Radians. Then when you press this in, it'll be 1.3 divided by sine of, right? And that's why you have to know 0.842, and I'm in radians, equals. Okay. Remember, 0.5s always round up. Anything 0.5 rounds up. So we're going to go 1.7, and now I'll do 100 because this is my last step. And then make sure you put units if there are any, and it's meters. Okay, so anything 0.5 rounds up. So I got this one. So anything 5 rounds up, right? So that one I think was 1.5, so I rounded it to 2. Any 5s round up. This one here was 4.2, so I left it at 4. So it's a 2 after. And make sure you put units. And that's it. Questions with that? Good?